Hello, everybody, and welcome to lesson 10-4, rational exponents and radicals. So what a rational number is a fraction, like a number divided by another number. Exponents is 2 to the power of 3. This is your exponent. And radicals are those roots. Usually we talk about square roots. So for example, the square root of 4 would be 2. But there are more roots than just the square root. So this is a lesson on the ones that are higher than the square roots. And I'm skipping a lot. I just want to show you a few basics. So in the future, if you come across it, you won't be you have seen it before. So in a radical expression, there's your radical sign. The number under the radical sign, this number right here, is called the radicand. Not that important, just so you heard it before. The number n in the crook of the radical, this one right here, there is usually no number, but if you add a 2, that makes it a square root. But the 2 is usually not written. It's understood that that is a 2. This number here is called the index. The index gives the degree of the root. So if this is a 3, it's the third root of a number. If this is a 4, it's the fourth root of a number. You can go up as high as you want. That's why the number is called n. It's called any number n will work for the index. You can go up infinite numbers. The radicand here is the number. The root tells you how often you have to multiply a number together to get this radicand. Thank God we have a calculator key. I'll show you how we can find that root. For a cube root, the index is 3. So that's called a cube root. For a square root, the index would be 2, which is the one we use most often. Yeah, square root of 9. The only thing is we don't write that 2. It's understood to be a 2 if there is no number. If there is no index, the degree is 2, which means square root. Okay, recall what you know about the square roots. By the way, this right here, you want to kind of highlight that. The index, the radical sign, and the number under the radical is called the radicand. Recall what you know about square roots. Since 5 squared is 25, you know that the square root of 25 is 5. It's the opposite of taking a power, okay? You also know, which is you don't really know, that's what I'm showing you today, that 25 to the power of 1/2 is 5, because the power of 1/2 simply means the square root. The third root of a number would be the power of 1/3. So this is how these are related. Yeah, the third root of a number can also be written as the number raised to the power of 1/3. It's not 8 to the power of 3, it's 8 to the power of 1 divided by 3. That's what the lesson is on fractional or rational exponents, okay? And here's the connection between them. So this is page 426. Let's move over to the next page. On the top, what is the simplified form of each expression? It says here the third root of a number 27. So there's a whole number that if you multiply it together 3 times, I'm gonna take that off so you can see it better. If you multiply this number together 3 times, will give you 27. What is that number? The third root of 27 is 3, because 3 times 3 times 3 is 27. The fifth root of 32 is also a whole number. In other words, what number multiplied together 5 times, the index tells you that, gives you the radicand of 32. It's the number 2. 1, 2, 3, 4, 5. 2 times 2 times 2 times 2 times 2 is 32. So in other words, 2 to the power of 5 is 32. So the fifth root of 32 is equal to 2. Okay, how do you find the nth root of a number a? For any number a, use your calculator, and I'll show you what's the key. So for example, the fifth root, I'll give you an example how to use it. The fifth root of 32 is the same as 32 raised to the power of 1/5. It's not raised to the power of 5, it's raised to the power of 1/5, which how you put it in the calculator would be 32, then your power key, then you must open must open parentheses, 1 divided by 5, and then you hit equal, and out jumps a 2. So this is the calculator keystroke. Your power key might be different. Mine is this caret. Hope you know which one it is on your calculator. Excuse me, a lot of times it's y to the x. Okay. All righty. Let's try another one. The third root of 64. You can use your calculator. You can put in 64 to the power of 1/3, which is 64 power key. Don't forget parentheses, 1 divided by 3 equals, and you'll see it's 4, I believe, because 4 times 4 times 4 is 64. So that's the connection. Yeah, it's the opposite of the powers, taking the root. The second root, or the square root of 36, it's 6. Okay. Down here at the bottom of this page, it explains the connection using, you can look at examples here. Nope, I don't want you to look at that. That makes it too complicated. I want to stay simple. The nth root of a real number, so it's the number raised to the power of 1/n is the nth root of that number. This is what I want you to. This is the algebra language. If you don't understand this, don't worry about it. But this is what you would see in a college book, math book, okay? In place of n, you can put any number, but the root, the index here must match this number. The next page, we're doing number 3. Yep, so we're going straight to number 3. Write each radical expression in exponential form. So it's the third root of a number s squared. So you're taking, do I want to do that one? No, not that one. Where are we? There, this one. This number 3. Write each expression in radical form. So you want to use a radical sign, okay? So it's the power of 1/2, which is the square root, and then you keep this together, 25x. All of that under the radical. Or you don't need the parentheses. As long as the 25x is all under the radical, or you don't need that number 2. You notice how I closed the radical at the end? It tells me this is where it stops. So these all work, these versions. This is the best one. Okay. Now here's how you don't write it. Not square root 25 and put the x out here. So you notice the x is not under the radical. The radical stops at the 25. Your x is outside. Incorrect. You need to make sure it's all covered. So I'm just going to leave that as an example how not to do it. Okay, it's all nicely tucked under that roof, everything. And the reason is it's in these parentheses. So the parentheses tell you what's grouped together raised to the power of 1/2. On the next page, we have a question, problem 4. Using a radical expression, these problems, they look hard, but they're really simple. Simply know what each variable means by reading the question. And substitute the given numbers. And one of the variables will be empty and you don't have a number, and that's the variable you'll solve for. Okay, those are always the same. The formula R, capital R, equals 73.3 times, there's a times button you don't see, 4th root of capital M cubed, and the little roof ends here, relates metabolic rate, metabolic rate, R. Do you notice how I'm looking? What is R? And I'll write it out here. All I'm doing is identifying the variables measured in calories. I'm just going to write that as well. Per day to body mass M. Capital M is the body mass. Okay, so I'm going to write that down. What's a body mass? It's like your weight, measured in kilograms. What is the metabolic rate? So we're looking for R, because it says here it's of a man with a body mass, and we know the body mass is 75 kilograms. So what the formula tells you is the metabolic rate is how many calories a person burns when in rest. So when you're just resting, sitting, laying, and you're not moving, you're still burning calories by having your heart beat, by letting your blood flow through your veins. So you still need energy to get all those bodily functions moving. And that metabolic rate counts how many calories are you burning at rest. And a body mass of 75 kilos is about 160 pounds. So it's an average size person. Oh, it's a man. So it could be 5.8, 5 feet, 8 inches tall, 160 pounds, average size man. Okay, so we're figuring out if he's resting, how many calories is he burning per day? That's the question. All right, let's look what we have. We have 2 variables and one is given. The M we know is 75 kilograms. And we're looking for R, which is the metabolic rate in calories. Okay, so let's plug in what we got. We're using the formula and a calculator, obviously. So we're going to rewrite R, we don't know, 73.3 times the 4th root of 75 cubed, because there's a power of 3. And then, so here's the thing, you got to start with correct order of operations. And I'm going to highlight in green what you need to find first. So you know, you need to find this number first, 75 to the power of 3. Put that in your calculator, equals. So I'm going to rewrite. I'll do one thing at a time. 4th root of 75 to the power of 3 is 421,875. Make sure you pull your radical all the way to the end. Okay, no sloppy radicals. Okay, next we're going to find the fourth root of this number. So this kind of gives you an idea what to do step by step. And remember, to find the fourth root, what do? We raise it to the power of 1 divided by 4 using your calculator. Yeah. It's the same as 4. Oh, come on, little machine. It's the same as 421, 875 to the power of 1/4. So this is the same as this. And this is how you put it in the calculator to get the answer. So I'm just going to rewrite. And now I'm using parentheses because this answer here is 25.4, about? I think so. And then you multiply these two numbers. Yeah, so you multiply 73.3 times 25.4 equals, and you should have metabolic rate R is 1,868 about calories per day, because it says here per day. Oh, my machine moved. Haha. Yeah, I don't know how to move it back. It covered up some things. So step 1, step 2, replace, multiply 1,860. So that's your metabolic rate, that if you rest, if you don't do anything, you'll still burn this many calories. But that's not enough. We eat more than that. So when we eat more than we burn, that's when we gain weight. So most of us burn probably close to 3,000 calories, or we eat 3,000 calories per day, but we only burn maybe 2,000 because we rest too much. So that's that extra 1,000 calorie goes to your body. So it gets turned into fat. So anyways, this is how you use these formulas. Not to be afraid, we're going to do the same for number 7. A company that manufactures memory chips for digital cameras uses the formula. And I'm going to underline the formula to determine the cost C. So C is the cost in dollars of producing N number of chips. So this company makes chips to put in your digital camera. And the cost of manufacturing or producing these chips is given with this formula. So however many chips, you would plug it in here, you'd work out each step, and then in the end, it would give you the cost. And the question is, how much will it cost to produce 250 chips? So we know N is 250, and we're looking for cost. Looking for C. So we plug in all the numbers. We don't have C, cost we're looking for. We start by recopying the third root of 250 power of 2. But now you close your, notice the 1300 is on the outside, makes a difference. So your root stops here. This is all that's under the root. The 1300 is extra. So that makes it a different answer than if you would put it under. So you want to close your radical to show where it stops, okay? So the first thing we're going to work inside the radical is always first. So we're going to find 250 squared, which is 250 power of 2 equals, I think I did that, 62,500. So I rewrite. That's a good start. You always this is a times third root. 250 squared is 62,500. Close your radical plus the 1300. The next thing we find is the third root of 62,500. And how do we find that? We take $62,500 to the power of 1/3. Third root, power of 1/3. The way you put it in your calculator, power, open parentheses, 1 divided by 3 equals, I have about 39.7. You want to round these numbers. So I rewrite, then comes this right here. I'm putting in parentheses the answer. You multiply next. Multiplying comes before adding. So that's kind of order of operation. So 120 times 39.7, I believe, is 4,764. And now plus 1,300. And then you add those two together. And my total cost, and I put a dollar sign because it's cost in dollars, is $6,064. And the question was, how much will it cost to produce 250 chips? That's the cost to produce 250 chips. And there's our answer. So these problems are not that hard if you understand what they're asking and you understand what each variable means and you know what to plug in and how to simplify it correctly. And one variable will be the one you're looking for. Yeah. So go ahead and take your time, copy this. You can pause the video. It sometimes helps to watch and then pause it and then take the notes down. That would be the best way with these word problems, especially. Now, next page, you're going to do your homework. We're on page 628. And remember, I said to you in my last class to attempt the homework. When I say to the best of your ability, it doesn't mean not doing it. It means you're going to try. And everybody has a different level of ability. Some of you might be able to do all of them. So some of you might be able to do half of them, but you need to try. So you come prepared to class. The 6th root of 64, the 4th root of 81. Did I do that one? Yep. You first find the 3rd root and then raise it to the power of 4. So try that. And then down here, 12 and 13. You need to write this expression in exponential form, which is with the exponent. And this one you need to write in radical. This is exponential form, and you need to write it in radical form. So you're learning how to switch back and forth from this to this form and from this form to this form. And then on the next page, we have nothing. So you can write skip this page. So I don't mark you down when I see your lessons, your homework. And then on the back page, one more question. On the bottom, we have this challenge, number 36. Again, we have a function. It's an exponential function. It's talking about cells that grows exponentially. The number of cells in the function is given by this expression where t is measured in hours. Write it out what t is. Remember, that's an exponent here. That's raised to the power of t. And n is the initial size. This is what we start out with. Yeah. So you could write this as y is equal to n initial size. This is your base. We have studied these, and you seem to understand. This is the initial amount. This is your base. This is the time. After 2 hours, there were 144 cells in the culture. That's your y. Okay, that 144 goes right here. What was n? Ooh, figure out what you started out with. How many cells were in the culture in 20 minutes? However, t is measured in hours. You got to review, what are my measurements? Hours, you cannot put in 20 because that means it would be 20 hours. You got to figure out, how can you relate 20 minutes and change it to hours? Okay, how many cells were in the culture of after 2.5 hours? Now that will match. You can put for t 2.5. All right, well, good luck to you. I'll see you later.